Hey, this is Jorge, and I'm a developer advocate at MongoDB. In this video, I'm going to cover the basics of unit testing in Rust, which means that you don't have to know anything in advance about unit testing. But I hope that you know something about Rust, that you can do basic development in Rust. And if you don't, let me tell you that we have a video that is an intro to Rust in this same channel, the MongoDB channel. Just watch it and come back here. And we are also running some webinars and workshops around writing microservices in Rust. You can also subscribe and join and learn some more Rust there. In this video, I'm going to cover 5 topics around basic unit testing in Rust. First one is the types of unit tests, and we will be writing one of each type. Then we will move into improving the quality of your testing code. And then we will talk about testing the not so happy path, which is also very important. I will also talk as the 4th topic as asynchronous testing, and I will finish by covering some testing tools. I hope the material is relevant to you and interesting, and if it is, please like the video and subscribe to the MongoDB channel. In this first section, I'm going to cover the basics of unit testing. I would like to talk about 3 topics. First, I would like to talk about why you want to have tests. Second, I would like to cover about how tests should be. And then I will cover the 3 types of tests that we will be creating. As for why you want to have tests, well, there are several reasons. But basically, you want to automate the process of verifying that your code base is not changing its behavior, that is performing as you expected it to. So you want your test to cover all of your code base and to be testing every time in a very fast way that nothing has changed, that your evolutions to the code are not affecting to the rest of your code base. Then, as I said, I would like to talk about how the tests should be. And the tests should be repeatable. They should be written in a way that you create the environment in a way that allows you to run the test in whichever order you wish, and you will still get the same outcome of the test. The test will either pass or fail, but it will be consistent, which is very important. We don't want tests that fail sometimes and pass some other times, but you are not changing the code. That's something that we will try to avoid by all means. Finally, I will talk about the 3 types of tests. The tests that we're going to cover are basically return test, state test, and interaction tests. So for the first one, you have a function or a method that returns something, and you want to test that the outcome of this function is what you were expecting it to be. Second is the state. You will operate on an object either through one of its methods or through another function, and you want to know that the final state of this type is exactly what you were expecting. So basically in Rust, we're talking about structs, sometimes enums, and you want to know that the final state of this struct is, in terms of their properties and so on, in terms of its fields, is exactly what you were expecting it to be. Finally, we're going to talk about interaction tests, and those are the ones that your code interacts with another type, either because it's part of the dependencies of the type or an argument to the function. There are other ways to inject dependencies, but those 2 are the most obvious ones. And by doing those, you will have your code exercise and you expect the other type to be invoked and used in some way, which is what you're going to test. So, as I said, a return test, state test, and interaction test. And those are the ones that we're going to be writing. I'm going to start by creating some code that will test the return value of a function or a method. In this case, I will be testing the return value of a method. And in order to do so, I'm going to create a new project from scratch in which I will write the code that will do the tests. So I call this project detestable.me, and I use cargo to create the project from the basic template. I go to the directory where the project has been created, and there I will be visiting the code using Visual Studio Code. Given the name of this project, we are going to write code here about the evil guys that we see in the movies. So we are going to create a type that is going to be called supervillain. And in order to do so, I'm going to put this type in its own source code file. So I'm going to create this file here in the same folder where the rest of the source code is, and I'm going to call it supervillain.rs. Okay. Now that I have the file, I'm going to define the type here, which is going to be called supervillain, and it's going to be abstract and public, so it can be used by the rest of the source code. Initially, this type is empty. It contains no properties, but we will solve this immediately. For the moment, I would like to add this to the main RS so it gets compiled with the rest of the project. So I'm going to add here mod supervillain, meaning that we want the supervillain.rs file included in the source code of this project. Okay, so I'm going to now switch to the supervillain file, and here I'm going to define a property which is going to be called first name. So this is the first name of our supervillain, and it's a string. And my first question to you would be, do we have to test this code that we have written? Well, I hope that we agree that you don't have to, because the act of defining an instance and giving it the value that we want to the first name property is something that is provided by the Rust language. And unless we are writing the compiler by ourselves, you don't have to do any testing for that. This is not source code that you have provided to implement that functionality. So next thing that I'm going to do is create a second property here, and I'm going to call that last name. Same idea, we're going to have the last name of the supervillain, and it's also going to be a string. Still nothing to be tested. But let's make things a little bit more interesting. Let's create something that is worth testing, and in order to do so, I'm going to create an implementation block which will contain a function that is going to be called full name. This function is going to be actually a method because it will have access to the properties of the instance, hence the ampersand self here, and it will return a full name string, which is going to be the concatenation of the two names. So I'm going to use the format macro here, and I will concatenate the first name, space, and the last name. I do know that this is not what every culture does in order to generate the full name of a person, but just bear with me. This is an example, okay? So now that we have something that is worth testing, where do we put those tests? Well, the convention in Rust is that we are going to have a nested module inside of the same file that describes the type that is going to be called tests. Usually this is plural, so it will have all the tests that you want here. But the contents of this module that are going to be each of the tests that you define, you don't want those to be included in the main binary when it gets compiled and run. So in order to avoid that, we are going to add an attribute to this module telling the compiler, please don't include this unless you are compiling the test version of this application or of this module, okay? So for the main binary, this won't be compiled and this won't be added to the binary, okay? Another thing that is useful doing here is having the access to the type that we have defined in the same file. And since we are in a different module, we have to provide visibility to the upper module, so to the super module. So we're going to have use super here, and that is going to be telling the compiler that we want to have access to supervillain without any particular beginning for the namespace. So that's basically where you put the test, and now we will be writing the test. We can use a snippet that is provided by default by Visual Studio Code. The snippet is called TFN, and as you can see here, by pressing enter, you are provided with this snippet of code, and the name of the test is something that you can replace right away. So you can say test something. Okay, so now we have our test here. And here we will be able to write a test as we will be doing immediately. Since we're talking about snippets, let me tell you that there is one that might be worth knowing. That is tmod. So let's use it here, tmod. And as soon as you press enter, you will see that the code that it generates is basically the mod tests that we have done manually. So it has the config test attribute, it has the same name for the module, even the user space, the namespace importation, and then it even comes with the first test predefined. So we are not going to use that now, but it is worth knowing that it exists in case you are writing your own mod test. Sometimes you even may have some particular needs that you want to solve through a snippet. So in case you have those, let me tell you how to create your own snippet. So you use Command-Shift-P if you're using a Mac, and then search for snippets and look for this option here that is pre-selected for me because it was the last one that I selected. Then you will look for Rust. In my case, there are existing snippets. In your case, it will probably be new snippets. So here you have the ability to define your own snippets. And using the syntax that is explained here very briefly, you can have your snippet defined and use in your Rust code. So I'm going to paste here the snippet, and this is the name of the snippet, and this is the prefix, that is what I'm going to type in order to get the snippet written into the code. And this is what the snippet contains. So it contains the test attribute, it has it defines the beginning of a function, and then you can replace the name. It has this placeholder that is test name, and this is the first parameter that is going to be entered by the user. Then it has 3 comments, the end of the test, and here it has the $0. $0 is meant to be where the cursor has to end when all the data has been entered by the user. So this is where the cursor will appear after entering the data. As for the 3 comments that I have added here, well, some people tend to refer to the 3 parts of a test in terms of given some environment, some context, when I do something, then something happens. So given, when, then. In my case, because my memory is weak, I prefer to use arrange, act, and assert, the 3 A's. So I arrange the things, I prepare the things, then I act on whatever I want to test, and then I assert what should have happened, okay? That's basically what we are going to do in each of the tests, and go with whatever mnemonic you want to go that makes your life easier. Okay, now that we have this, I'm going to close the Rust JSON file, and I'm going to use it here. So now that we have defined a snippet for the test, let's use it. Let's go to the code, select the existing test code, delete it, and use the prefix for the snippet. So that would be TFN. And as you can see here, there's no need to type the whole thing, but just enough so it shows up here in the list. We can now use the arrow keys and enter to get the snippet inserted in our code. The first thing that we can do with a snippet is to customize the name for the test. And that's obviously something that we want to do because we want to have a name for the test that tells us what is happening if the test fails. And it is not enough to use the name of the functionality that you are testing. So full name here wouldn't be a good name for the test, because there are different ways in which you can test the same functionality, and you may expect different outputs, different outcomes of the test, depending on the context. So you obviously cannot write a whole paragraph here, but you want to be generous in the number of words that you use here, so they tell you exactly what is happening in this test. You don't want to go and read the test code in order to understand what is happening there. In this case, I have decided to go with full name is first name space last name, which tells us exactly what we are going to test here and what we expect. And with that said, we can use the tab key and we move on to the next dollar number in the snippet. In this case, because there's no other text entry, we move to the $0, which is the last point of the snippet where your cursor is going to be moved to. So now that we have the full test written, we're going to go step by step through these different parts, the range part, the act part, and the assert, in order to complete the test. The range is where we prepare the control environment. The act is where we exercise the method that we're testing. And the assert is where we do the assertions about what we expect to happen as a result of our interaction. Okay, so let's go step by step, as I said, and let's start by creating an instance of the thing that we're going to test. So this instance is going to be, let me indent this properly, is going to be an instance of the supervillain, which is the type that we're testing. And we store this instance in a immutable variable called SUT. SUT stands for System Under Test, which is a way to tell anybody reading the test that this is what we are focusing on testing. The SUT is what you want to test. And we have provided some values that are literal values to the properties. So the first name is going to be Lex, the last name is going to be Luther. And we convert both to strings because that is what we need in order to create an instance in this case. Okay, so now that we have created an instance of the type that we want to test, let's exercise the method that we want to test. So we go here and we invoke the full name method, and we store the output of that method in the full name immutable variable. That has exactly the same name as the method, but you could have called this anything else. In this case, I have decided with full name to mean that this is where we store the output of the method. Finally, now that we have prepared the context and exercised the method that we want to test, I want to make an assertion. And the assertion is going to be assert equals, which means that I do mean that these two things are going to be equal. And I want to compare the full name, the output of the full name method, with this literal value. Some people may feel tempted to do some computation to get the expected value. In this case, the literal Lex space Luther. And they may write here some format, macro, and whatever. I recommend you not to do this. And the reason why my advice is not to do it is because in case your test fails, you want to know that the error comes from the actual code, the invocation of the full name method, rather than from some mistake that you made in the computation of this expected value. Okay, so now that we have this, let's go and run it. In order to run it, I go to the terminal and I use cargo, as I always do, to compile, build, run anything in Rust. So here I'm going to use cargo test, and with this cargo test, I create another binary which includes the test and runs each one of the tests. In this case, it's running the only test that we have, so it's running one test, And it is telling us the name of the test that it has been run and that it has passed, that it is okay. Then we have a summary for all of the tests that we have run. In this case, we only have these tests, so it doesn't provide us much more information, but we will in the future have more tests, and this will give us the summary of how many have passed, how many have failed, how many have been ignored, and so on. Okay, so now that we have that, let me make a few comments about the assertion. It is very important that the assertion that you use is explicitly telling what you expect from the test. I mean, this is something that is important. If you forget to put an assertion here and you just comment this and run the test again, you will see that the test passes. These warnings here are because there are some variables that are not being used, but the test is passing and it won't detect your mistake. Yes, because you didn't have any assertion. The assertions must tell what should be correct in order to pass the test. And also, the assertions must refer to the code. If you put here some other assertion that is completely irrelevant to the code that we run, for example, that these two strings that are equal, which obviously are because they are the same string, again, we will have a test that is passing, but that is not telling us anything about the code that we wrote. So what you want to do is to have good assertions that are very explicit about what you are expecting here. And you can add some more, let me delete this one. Let's put this one here in the terminal because this is what we're going to do next. And here I'm going to add the assertion, not this one, sorry, but the assertion, a little bit more explicit assertion. So this assertion is now comparing the full name, Lex Luthor, with the outcome of the invocation, and it provides us with additional information. Because sometimes you don't get enough information about what's happening. So what we're going to do is to run this new assertion here. I'm going to show you that if I make a mistake, and that's something that you want to do, that you want to check that if you make a mistake in your code, your test fails. Because unless you have seen a test failing, you don't know whether it is good enough to catch your errors. So we are making an error on purpose here, and we're going to run this here. Notice that in this case, I have used not only cargo test, but I have used the command line. This is a Mac machine, and it will tell me test pass if everything went okay, and test fails in case they did. So I'm going to go here, execute.
Test failed.
And it tells me that the tests have failed. And not only that, here is telling me the values of the things that were compared, the left and the right. And here I have the message that I added to the assertion, the unexpected full name that I have here. Okay? Okay, with that said, let me fix the code. Now I know what I have to fix because the test is telling me so. And now I can run this and
Test passed.
get a test pass message. The next type of test that I would like to show to you is a state test. A state test is the one that you use when the function or method that you are testing changes the state of an instance of a type. So you want to verify that the final state of the instance is exactly what you were expecting it to be. So in order to write that test, we're going to create a new function that does that modifies the state of a supervillain. So we're going to start by defining the function. Defining the function here is going to be a new function that is called setFullName. And setFullName takes a parameter, which is the full name, the string that contains first and last name separated by spaces. So what we're going to do is we're going to split that string using the space. So we will divide it into components in a vector separated by the spaces that the string contains. And then we will use them to assign them to the first name. We will assign the first component of the vector to the first name and the second component of that vector to the last name. I know that this can fail in many ways. And that is something that we are going to ignore for the moment because I will be talking about testing the not so happy path later on in this video. For now, let's test that this does exactly what we are expecting it to do in the happy case. So let's write a new test, and in order to do that, we move into the test module that we wrote before, and here we're going to add a new test. So for that test, we use the snippet which we created. So this is going to be tfnw and enter. And for the name of this new test, we're going to use set full name sets first and last name, which is very explicit. It tells us what we are expecting it to happen, and we are going to go and write that test step by step. So here I'm going to start by the arrange part, and in order to be able to change the state of an instance, I need an instance. So we're going to create the instance exactly as we did before. We're also going to call it suit as we had, and is going to be created with the same values, with Lex and Luthor for first and last name respectively. And then we're going to act, and act means exercising the method that we are testing. In this case, the method that we're testing is set full name, so we are going to call suit.setFullName with a new string. And I want to emphasize that this has to be different. It cannot be Lex Luthor, because otherwise we wouldn't know if the value of first and last name has been changed properly or it had the value that we initially assigned to them. So it has to be different, and in this case we are going with Darth Vader. And finally, we're going to make an assertion, which is going to be actually two assertions, because both of them point to the same line of code. So here we're saying, I want to be sure that the first name is Darth after using set full name, and I want to be sure that the last name is Vader. Okay, so now that we have defined that test, let's go to the console, and in this terminal we can write cargo test as we did before and run the test. As you can see here, it has run two tests. The one that we had previously, the full name is first name space last name, and the new one, set full name sets first and last name. And both of them have passed, are okay, and the results summary is also now including the second test that has passed. Okay, so far so good. Okay, I know what you're thinking, but this is not the way we do things in Rust, Jorge. And I agree with you. We don't create an instance with dumb values in order to modify the instance later on and then have the values that we wanted in the first place. We usually use the from trait or the try from trait instead. So from the initial values, we create the instance that we wanted in the first place. So let's do this here, and let me show you why I didn't choose this way of doing things, which I will start by implementing the from trait, and this is going to be a trait that is implemented on the strings slice and for the supervillain type, and I need to implement the associated function that is required for that trait, which is the from associated function, and it takes an argument, which is the name, the full name, and it returns an instance of the type that we're implementing this trait for, which is supervillain, and that's why I have the capital letter S self here. And here inside of this function, we're going to do exactly the same that we were doing before. So basically, what we will be doing is we will be splitting the components of the full name, and instead of assigning those components to the properties of an existing instance, because there's none at this moment, we're going to create a new instance from scratch, and we're going to return that instance. That is the main difference. I mean, like in this case, we will have to be testing the return value. And that's something that we had already done in the first test. But since we're here, just for fun, let's create a test for this new associated function. So let's go to the, module in which we have the test, and let's create a new test here. So I'm going to use the snippet that we were using before, and I'm going to change again the name of the test, and I'm going to use from string slice produces supervillain with first and last name. Pretty clear again. It tells us what it's expected to happen, and now we're going to write each one of the parts here. So to be honest, there's not much to prepare here. Instead, we would like to act on the method that the associated function that we have created, and we are going to create an instance, in this case the SUT. We're going to create it using that associated function, which is using supervillain : from, and then the expected, the string that we wanted. Finally, we're going to do the assertions as we did before, and those will be the same assertions that we had before. For the first name, we want it to be Darth. For the last name, we want it to be Vader. And now we have written the test. Nothing to arrange here, no conditions are required in order to have this test created. And we can now go to the console, to the terminal, and use cargo test, run it, and hopefully we will have 3 tests passing. Okay, so 3 tests, and okay. So the summary tells us that 3 tests have passed. That's perfectly fine. The writing tests for return value and a state, I would like to share with you how to write a third type of test. These are going to be interaction tests or behavior tests. The point here is to verify that the method we are testing causes the interaction of our function or method with an other instance of a type. So let me write some code that implements that, and then we will figure out how to test it. Well, as you know, the history of villains with weapons is a very long one, and since we're talking about supervillains here, we would need something better than weapons, and we're going to define mega weapons. Mega weapons are anything that can be shot, and if you shoot a mega weapon, then you are using it. So now that we have defined that mega weapon, instead of a particular one, we have defined a trait. Anything that has this function is a mega weapon. We're going to write some code that implements that interaction with the mega weapon. We're going to implement the attack method. And in the attack method, we're going to receive a weapon as a parameter, that is anything that implements the mega weapon trait, and we are going to use it. So basically, when we are attacking, we will take the weapon and we will shoot it. Okay, that is the code I would like to test. So let's think now how to test it. And in order to do that, I'm going to go to the test module, and I'm going to add a new test here. So that is going to be using the prefix for the snippet that we defined before. And the test that we want to write is the one that verifies that when we use the attack method, the weapon is shot. So we're going to call this method attack shoots weapon. Okay. Now that this is clear, let's go and write each part of the test. So let me save this and let's go step by step. Since we need a supervillain to shoot the weapon, we need to have a villain. So this supervillain is going to be defined as we did before. And here I'm going to use the same definition that we use in some of the other tests. So we are going to have a system under test, a suit that has the same first name and last name properties. Now that we have the supervillain, we can use the method that we want to test. So that would be using the attack method, and we need to pass a weapon to that method. That weapon is going to be anything that implements the trait, but we haven't defined any actual type that implements that trait. So the option that we have here is to define a type that implements that trait, and we will use that particular type just for testing, not for the real application. So this is going to be something that implements the mega weapon trait, and we're going to define it inside of the test, inside of the module tests. So I define that type, I call it weapon double, and a weapon double could be anything, but in this case, the important thing is that it implements the mega weapon trait. And that means that it has to have the shoot function, the shoot method in this case. So by having this method, I can now use an instance of this weapon double as the thing that we use to attack. So let's go and let's define that instance here, and we're going to insert it here, and that weapon is the one that we're using in the attack method. Okay, so we have our range, we have created an instance of a supervillain, we have created an instance of a weapon double, something that we can use as if it were a weapon, and then we invoke the method that we would like to test, and we would like to make assertions, but those assertions are not going to be about the system under test, but rather about the weapon. So I would like to make some assertions, but what do I assert about the weapon double? Well, I would like the weapon to have some memory. I don't need it to actually shoot anything, but I want it to remember when it has been shot. So I will go here and define a property inside of this weapon double. And this property is going to be used to memorize when it has been shot. That means that when we create an instance, it has to be false. And yes, I know we could be using the default trait, but in order to make it a little bit more explicit, I'm going to implement weapon double, and then I'm going to define an associated method to create an instance, which it is commonly done in Rust. I will call it new. And inside of this method, what I'm going to do is define a weapon double with the isShot variable set to false. So now that I have this constructor for the weapon double, it would be a good idea to use it. So now and before I use it, I would like to remember to set the isShot to true in case we have shot the weapon. So when the method of the weapon double is invoked, we will have this property set to true. Okay, now I'm ready to create a weapon that uses that constructor. So I'm going to create that instance of the weapon using this constructor. And here I would like to make an assertion on the weapon rather than on the SUT, on the system under test. So what I'm going to do here is to say, hey, assert that the weapon has been shot. And if this were any other language, we would have been done by now. But this is Rust, and there are a couple of things that we have to fix here. Well, the first one, and let me start here at the bottom, is that we are trying to modify isShot, but in this method, we're only getting a shared reference to the instance of our type. That means that we cannot modify any of the properties. The other problem that we have is that the way that we define attack was by taking an instance of anything that implements weapon, not a reference, but an instance. That means that we are moving this weapon into the attack method, and it disappears after that, so we cannot use it to do the assertion. So let's go step by step and let's try to solve these problems. And in order to do that, I'm going to start with the second one, with the problem with modifying the data once we have a reference that is a shared reference only. This is a problem that can be solved by using interior mutability, and this mutability is achieved by using a ref cell. So here I'm going to replace the definition of this isShot property, and I'm going to define isShot as a ref cell that contains a bool value. And that ref cell, obviously I need to import the definition of the ref cell to bring it into the namespace. But after that, I need to have the proper usage of that. So when I initialize this, I need to have this definition. Let me using the ref cell and the constructor of the ref cell. And when I modify the value when it is shot, I also need to be aware that this is a ref cell. So I would like to go here and use this as a ref cell rather than as a plain property. Okay, now using interior mutability, I am able to have a weapon that doesn't require to have a mutable reference. But how do I solve the other thing? Well, the problem here is that, as I said before, in the way that I have defined the method, and let me go to the method for a second, I am taking ownership of the weapon. And that weapon is shot here, but it cannot be used after this scope. That means that the weapon is dropped here, and we could use that, okay? So let's write an implementation of the drop, the drop trait here, and implement it in a way that can help us to do this verification. So here I'm going to implement drop for weapon double, which means that I need to implement the drop method. That takes a reference to a mutable self. And here what I'm going to do is verify if I did the shooting, and if I didn't, I will throw a panic. Panic is the way that assertions complain about not being okay with the assertion. I mean, like when you do an assert equals, what it happens when things are not equal is that it throws a panic. So basically what I'm doing here is doing the same manually. So I'm going to write an if self is short borrow in order to use that doesn't equal true, then I'm going to have this panic thrown so I can be aware of this problem happening here. Okay, so now that I have this, I'm going to remove the usage of the assertion because I don't need it anymore. I'm not interested in the actual assertion. I'm going to make this a comment, and the rest of it is going to be good enough for the testing. So I go into the console and I use cargo test. So again, cargo test. And, oh, sorry. So I made a mistake and I implemented here, but it should actually be inside of the module, on the test module. So let's move it here, which is where it should be. And that implements drop for the weapon double, which is implemented here, obviously. Sorry about that. And now that we have that, we should be able to run it as expected. So let me try again. And it passes. But how do I know that it could be failing? Well, I could go to the actual code and comment out the line in which the weapon is used and run the test again. And as you can see here, the test has now failed. So yeah, we're ready to test something, even though we are passing ownership to the method in this case. Okay, so let me comment this. Let me remove the comment here. So we're done. But let me tell you how I would recommend you to solve this problem. Instead of all this magic with the drop method, I would prefer to make the code testable, which means that I need to go to the definition of the method here, and instead of taking ownership of the weapon, which makes no sense at all, I'm going to replace that with a definition in which, let me remove the extra, in which the attack method takes a shared reference to the weapon. And so it doesn't have to worry about the weapon not being available after that. So then we can go to our test, and where we were writing our test here, we can remove the implementation of drop. Let's remove that thing. We don't need that anymore. And here I'm going to use in the test the assertion, but instead of this assertion, which wasn't used in the ref cell, I'm going to write, that would be for the attack, and that would be for the weapon. So let me move the attack here. And here I'm going to have the attack that uses the reference instead of passing ownership to the method, and the assertion uses the ref cell in order to verify that it has been shot. Okay, so now that we have that, we can go to the console and again verify that everything goes fine. So we run cargo test again, and now we get the test passing again. In this second section, we're going to talk about the quality of our testing code. And let me tell you that it is as important as the quality of the rest of your code base. So we are going to take some steps to reduce repetition, make it more robust, and make it easy to maintain and evolve. That's basically it. The first thing that we can do in order to improve the quality of our testing code is to use constants. The reason why you want to use constants is because it happens very often that you have literal values that are repeated in several places of your code. And you want them all to be consistent. You want them all to have the same actual value. So even if you're a very good typist, chances of making a typo are not zero, and spotting where the typo is across the many different instances becomes very hard and time consuming. Also, if you use constants, you get autocompletion for free. So let's do it. Here I'm going to define two constants, one for Lex, the other one for Luther. So the primary first name and the secondary, and the primary last name. And here I'm going to try to use it here. So I'm going to use the first name and the last name here, and I'm going to have this code instead. Same thing happens here. So I'm going to use the code here and remove the old code. And also here. So we are going to remove the old code too. And that should be it. Now that we have replaced all the instances, we should go into the terminal and then try to run cargo test and verify that our tests are still passing, which is the case here. Let me add another constant for the full name. So here I'm going to add another constant for the full name, and I'm going to replace that constant with the code that uses it all around too. So I'm going to remove this one, and not here, not here. That's it. So again, we go to the terminal and we try to verify that everything is still passing. You can do the same thing for the secondary name. So let's try to define constant for Darth Vader. So let's go here, and yep, we have now the constants for Darth Vader, and we can use those. So here I can have the full name, set full name using this new constant, and also I can go and use it for the assertions here. So same thing can happen with the test that we did for the from implementation. So we can use it with the associated function, and here we can also use it for the assertions and get rid of the old code. So yeah, let's remove this one that is still remaining here, and that should make it. There are no more literal strings. All of them have been defined here, and if you make any mistake here, it is easier to find it. So let's finally check that we did our replacements properly, and here we go. If you review the testing code, you will realize that there is some initialization that is repeated in most of the tests. So for example, in the first test, we have the initialization of the system under test, which is an instance of a supervillain and uses these values for the fields. If we go to the second test, we do exactly the same initialization for the system under test. It is true that we don't do that for the third test, but we repeat the same initialization for the fourth one. So 3 out of 4 are using the same initialization for the system under test. And a fair question is there a way to avoid this repetition? In other languages, the tests would be methods of a type, and we would use a property or a field in order to share the initialization of these values. Here, in Rust, the tests are independent functions of a module, so it is not that easy. What we could do instead is we could create our own instance that is going to hold this information. So we're going to do that here, and I'm going to define a context struct. This context is going to contain the things that we want to share from one test to another. And in this case, this is going to be the system under test, and which is an instance of the supervillain type. Okay, I also would like to be able to initialize these values and do this initialization in a way that can be reused. So I'm going to do an implementation of functions for this type, for the context type. And the first function that I'm going to implement, an associated function, is going to be the setup. This is where we plan to create the instance of the system under test. So here I'm going to create a context, and I'm going to use this creation, this instance of the context, as we were doing before. We're going to return exactly the same instance inside of the context. Okay? The other function that we could create that is also normal in other environments is the teardown, which I'm going to leave here just for the sake of completeness, but we are not going to use during this example. So we have defined a context, and we can use the teardown and the setup. And how do we use this code in our test? Well, we need an ancillary function that is going to be the one that runs our test using this advantage. So we define this function in a way that can be reused. So we're going to call this function run test. We will take the test as a function or a closure that is the parameter of this function. And I'm going to be a little bit more specific about what T is. T is anything that implements the fn1 trait and that takes a mutable reference to the context so that it can be modified, and that returns nothing. So that is the type of function or closure that we're expecting here. Now I would like to decide what the implementation is going to be, and here what I'm planning to do is what you would normally do for all the tests. You will create an instance of the context using the associated function, then you write the test using this context, and finally you tear down, you clean up whatever you have created before. That is the basic structure that we follow in other environments. What is the problem here? Well, the problem is that, as I mentioned before, when a test fails, it throws a panic. And that panic is something that stops the flow here. So by stopping the flow, we would never do the teardown. How can we avoid this from happening? Because we do want to have the teardown to take place even when the test fails. So one way of doing this is to use a different way of invoking this test in a way in which we can say, if this fails, hold the value, hold the panic until I tell you to continue. So what we're going to do here is invoke this test as a panic that is catched if it happens. I'm going to obviously delete the other one. And I would like to have this panic imported as import standard panic, so I can use it here. Okay, now I have this result, and the thing that I would like to do is, if I got something that is a panic, then I want to use this panic as it was planned in the first place. So this is basically what we are going to do. We are going to create the context, run, but don't panic, do the cleanup, and if there was a panic there, we will complain, okay? That's what we are planning to do here. So how do we use this run test function? Well, we are going to go to the first test that we define, which is this one. And here I'm going to use, let me go here. I'm going to use the ancillary function that I defined. And inside of that, I'm going to put the contents of the test that I had previously. So I'm going to remove this thing and put it here. Okay, so let's go step by step. As I said before, the first thing that we're going to do is to create the instance of the context and initialize the supervillain. So we don't need the supervillain anymore. Let's get rid of this. The other thing that we would be doing is that now the system under test is not a local variable here, but rather the field of the type that is in the context. So what we are going to do is use this type to obtain the system under test and execute the full name method. And finally, the assertion is going to be exactly the same that we were using before. So in order to be sure that this works, and let me spoil it, is going to fail, you want to run it and check that it passes the test. So let's go to the console, to the terminal, and let's run the test. Okay, so it is compiling, but it's saying that I'm planning to move the data here, and this requires to be something that is unwind safe. So what I can do is to modify the type in a way that matches the requirements, so the thing that I did in order to catch the panic works. So let's go to the ancillary function here, and let's implement this in a slightly different way. The first thing that I would like to do is to define a wrapper. The wrapper is going to be defined here. So basically the wrapper is using the assert unwind save and uses the context that we have defined previously. Okay. Then when we invoke the test, the closure or the function that defines the test, we are going to replace this piece of code with this one, which is similar, but now it uses the wrapper instead of using the actual context. So now this complies with that requirement. The only thing that I need in order to complete the requirements, the constraints for this type, is adding a constraint here that is going to be that this type T also implements panic and unwind save. So that should be it. And now if I go to the terminal and run cargo test again, I should get this passing. Let's see, it's compiling, running, and yeah, everything went fine. Okay, so now let me close the terminal for a second. We could run every test using this infrastructure. and we would have the ability to replicate this for the other tests, and it should work properly. Well, there's one more thing that we can do. I mean, like what we have done here is the manual definition of this context, but there is a crate that does exactly this. So what I'm going to do next is I'm going to do a cargo add of this crate that does exactly what I did here. And I'm going to add it as a development dependency. So hopefully this is going to be fast, and I'm going to get the crate installed. Let's try again. Oh, I don't know why this was repeated, but this should be it. Okay, so now that I have added the crate, I can replace the code using the one that is provided by the crate instead of using this ancillary function. So what I'm going to do here is define the code in a way that uses this new crate that I have defined. So I'm going to, instead of implement context, I'm going to implement the trait that is defined in this crate. So this is going to be it. And in order to be able to use the trait, I need to import this from the crate that I have added as a dependency. The name of the functions are on purpose the same ones that are defined in the type, in the trait. And now that I have defined this, the only thing I need to do is modify the test by, let's go to the first one, defining the definition of the test function. So it uses this context. I'm going to delete this one, get rid of the thing that we have here, and I would also want to get rid of this thing. So let me check that I did this properly. And it is still complaining because, as you know, tests don't take any arguments, but we are getting one here. So what we need to do is to use an attribute that is going to be used as a macro here, and will take care of unwinding this into an actual function that is the test, which will do what we were doing with the ancillary function run test. So the only thing that I'm missing here is that I need to import this macro. And now the test is simpler. It takes the context and it does exactly what we were doing before. So let me go to the terminal. Let's run cargo test. And as you can see, the test is passing again. So we can remove this function here that we don't need anymore. And here we go. And that should be it. So hopefully this is what we needed to have all the tests running properly. There is one more thing that I would like to share with you regarding the quality of your testing code. Sometimes you want to share code between different test modules, or even just constants that are defined in one and can be used in some other tests. So let's imagine that we're going to reuse these constants here, and let's see how to do this sharing. So I'm going to go to the source folder and I'm going to create a new file, and I'm going to call this file test_common rs. And in this file, I'm going to define the constants. So here I define the same constants that I had in the module for the tests. Now I want to be sure that these get included in the compilation when the test is being run. So in order to do that, I'm going to go to the main RS, and here I need to include the module, but I need to do it in a way that it only gets included if the test is being run. So I will use the test attribute in order to ensure that this module only gets tested, only gets compiled when the test attribute is there. Now that I have done that, I can go to the supervillain code, and here I'm going to use this crate. So for example, here I can go and use this crate here, and now use the namespace to ensure that I'm using the constants from this share file. So here I will use test common : primary full name, and here I will do the same for the secondary. So the same here, also here, and here. And finally, I think that should be it. Let me check that I am not missing any. And I'm going to remove those from here. And let's verify that everything is being done properly. And the reason why here I'm missing a couple. So in the initialization, I also need to do this. Common, : Okay, so my only restriction is that these are not public, so I have to go to the test common and use pub in front of all of them. So I will use pub here, and let me copy this and also here, and finally here. Now that I have this, the constants should be available everywhere. And if I go to the terminal and run cargo test, cargo test, all the tests pass without the constants here, but rather shared in the other module. The advantage of having a security net is for when things go wrong. So it is good to know that everything works as planned and that we get the expected outcome. But if something goes wrong, we also want to be sure that we are able to respond as expected. And that is what we are going to do in our next session when we try to test the not so happy path. All the tests that we have written so far were aimed at verifying that the code that we wrote was behaving as expected under the expected circumstances, the so-called happy path. However, we know that our unit tests should do better than that. They should cover the edge cases. They should protect us if anything goes wrong. So in order to talk about that, I'm going to add some code to our setFullName method. Let me remind you that when we were talking about the setFullName method, we were receiving a name and splitting it using the spaces, assuming that it was going to contain two words and that they were going to be separated by a space. And that might not be the case. So let's be explicit and let's add some code that would help us react if anything wrong happens. And here I'm going to add this code that is going to cover the case where we don't get two components from the name string, but rather any other number. We're from 0 to infinite, basically, but not two. Okay? Now that we have included this code and that we know that it's going to panic with this message, name must have first and last name, we are going to test it. So let's go to the test module, and here, right after the test that we wrote for the successful case, for when we were passing the proper name, we're going to go with a different test. And let me emphasize what I mentioned before about the names of the test. If we were talking about set full name as the name for the test here, we will have a hard time to define another test for set full name here, because we're now going to test a different behavior on set full name. So let me use the snippet that we define, and here I'm going to go with this name, set full name panics with empty name, as the name for the test. And let's go and use the infrastructure that we defined before in order to reuse the setup and teardown. And here I'm going to use an attribute, the test context with the context type, and I'm going to use the argument for the test that I'm writing. Okay, so at this point we have a context that contains the system under test with Lex and Luther, and what I would like to do is to act on that. So I would like to exercise the method, the full name, set full name, and in this case we're going to use an empty string, which is obviously going to panic. But what do we do with the assertion? Well, there's no assert panic here. So instead, what we should do is to use another attribute here that is going to be called should panic. And then we are telling the test runner that, hey, if something goes wrong here inside of this test and it panics, that's what we are expecting it to happen. Okay? So let's try the code and let's run it. And we're going to use cargo test again, run the tests, and as you can see here, now the 5 tests are passing, including the one that we have just written that is called set full name panics with empty name. Okay, I could be a little bit more explicit even, and I could go here and define another attribute, or rather the same attribute but with more data, and I can be explicit about the message of the panic that I'm expecting. In case I get another panic, that won't be successfully passing, but that's what I want to do here. So what I can now do is get rid of the previous attribute and now run the test with this expected message that was the one that I defined in the code before. So let's run it again and let's see that it also passes. Yay! Now that we have improved our set full name method implementation, we would like to do something similar with our from trait. Instead of having this fail silently and panicking when a wrong string is passed, we would like to be able to return an error. But before we do that, I'm going to go and disable the method that we have defined for the from associated function. So here I'm going to add an attribute that is called ignore, and I would like to show you what it does and what it doesn't do. So now I'm going to run the tests, and I use cargo test here in the terminal, and as you can see, this test is now flagged as ignored, and it is also included in the summary as one test ignored. So now the test that we wrote for from is not going to be used anymore. Okay, so let's go to the code and let's go to the trait from implementation and modify it. Well, in order to return an error, you want to implement a different trait, similar but different. So this is going to be the try from. Instead of returning the type that you implemented for, it returns a result type which can be either the type if everything goes fine, or an error if anything goes wrong. So I'm going to get rid of the declaration of the implementation for the from trait. And obviously now it is complaining that the method, or actually the associated function that we have to implement here, is slightly different. So the name of the associated function is try from instead of from. And again, I'm going to get rid of the other one. Notice that it returns self, so supervillain, but it returns an error that is an associated type that has to be defined here. So I would like to be able to use an error without having to go through all the burden of defining an enum and making it an implementation of errors. So I'm going to use anyhow, the crate that help us simplify dealing with errors. And I'm going to go to the terminal and use cargo add anyhow. And that will be a dependency that is not for development, because it is also present in the production code here, and that we're going to be using as the error implementation in order to simplify things here. Now that we have that, we would like to go and define the associated type as anyhow error. So we are going to say, hey, when we're talking about an error here in try from, we mean anyhow error. And the other thing that we would like to do is to surround this supervillain in an OK type, an OK case. So we are going to return the successful value, and it's going to be exactly the same, but with preceded or surrounded by an OK case. So that is now matching the definition, because it is a result, in this case an OK result, with the proper value of the type. But we haven't still solved the problem with the error. What happens if we have less than 2 components? So let's go and write this code here. And if we have less than 2 components, let's create some code here that is going to be able to deal with that. So if we have less than 2 components, let me delete this curly brace and have it here. So I'm going to say, if we have less than 2 components, I will be returning an error, which is going to be defined by anyhow, and it doesn't allow me to use the automatic import, so I'm going to do it manually. I'm going to go here, and I'm going to import anyhow in the space, in the namespace here. So this is going to be use anyhow, colon, anyhow. And that should make it. And we should have anyhow macro imported here. Okay, so coming back to the code, when we have less than 2 components, we're going to return an error, and the error is going to be using the anyhow macro and having this message inside. If everything goes fine and we have exactly 2 components or more, we're going to define a supervillain with the first 2 components as first name and last name. Okay, now that we have the code, let's go and write a test. So one thing that I would like to show you before writing the test is that even though the test is being ignored, that is not enough when you want to run the test, because now we have code inside of this test that doesn't compile anymore, and the code is not run, but it is compiled. So this is not going to be working for ignoring code that is not properly written. And since we don't have the from associated function supported anymore, we need to change the code. Okay, so let's do that. Here, we're going to go and use try from instead of the from method that we were using before. So we're going to define a supervillain with the try from and the secondary full name that we were using before. And we get rid of this method now. this statement, rather. And now we would like to go and use the proper assertion. And the problem is that here I'm getting a result, which could be either an OK or an error. And what I would like to compare is the content of an OK type, only if it is OK, because if it is an error, then I did something wrong. So what I'm going to do is to use a let statement here, and that is going to be using pattern matching to verify that result is an OK that will contain what I now define as the system under test. And if it doesn't contain an OK, then it will panic and then the test will fail with unexpected error returned by try from. Okay, so now, because the SUT in this line has to either be successfully defined or the code will have panicked, then I can continue with the assertions that I had defined previously. And I can run those and hopefully have them pass the test, okay? So, important, I need to remove the ignore part here. Otherwise, it's still ignoring now it's compiling, but it is ignoring the code. So I run the test again, and yes, everything is passing and everything is back to normal. Let's add a test for when this code fails, for when I provide a string that doesn't match my requirements for a string in the from implementation. So what I'm going to do again is to use my snippet and define a new test that is going to be from string slice produces error with less than 2 substrings. Perfect. So now I go and I use the same structure that I did here, but for a case where my data is not the right one, the expected one. So I'm going to go here and I'm going to add the creation from using the try from method, but from an empty string. And obviously this should report an error. And what I'm going to do, let me move this into the act part. And what I'm going to assert here is something similar to what I did before. But what I'm going to say is I would like it to be, let's go to the beginning of the line, I would like to match this result with an error. And if it's not an error, because that's what I'm expecting if I'm passing an empty string, I am saying, I'm panicking and complaining, hey, you returned something and I wasn't expecting to get something, some value out of this from, actually try from invocation. Okay, so let's go and run this again and see if it passes. We should now have 6 tests and all of them should be passing. There is an alternative to using this let else expression if you only care about the OK case. That would be using this line here that it uses expect to unwrap the contents of the try from. So then you have the SUT, which is what you are interested in. And if you don't have an OK case, then the expect part would unwrap and panic. So let's use this thing instead of the let else expression that we had before. So let's remove this one. And also we don't need to extract the system under test from the OK case because it's already extracted with the unwrap part. So now I can go to the terminal and I can run cargo test, and as you see, it works exactly the same as the code that we wrote before. Also, I would like to share with you another way of doing this, which is one that I don't use very often, but I want you to be aware that it exists. So instead of using this unwrap, we can use the question mark operator. So we can go here, select the 2 lines, delete them, And now we are going to be using this operator here that, as you know, bubbles up the error in case it happens. The problem here is that you need this function to be able to work with the error. So now we are going to need to say that this returns a result of type empty or anyhow. Okay, so that is okay, but it's still complaining because that's not what the function returns in the OK case. So we need to go to the last line of the test function, and here I'm going to add a return that is going to be OK with an empty value here. Okay, so now I can go to the terminal and run the test again, and it passes exactly the same as it did before. As you know, Rust didn't come with asynchronous capabilities built in. It has taken a while to come up with a solution that everybody liked. But now that we have it, more and more code is becoming asynchronous. So it is important to know how to test it. And this is what we are going to cover in this next section: how to test asynchronous code. So let's explore how to write asynchronous code. In order to do that, I'm going to have some new method that is going to be implemented asynchronously. But I need to have the cargo toml modified to include the Tokyo crate. And here I'm using three features. So I'm using macros, time, and runtime. And macros and runtime are meant for the test, and time for a delay that I will be introducing later. So now that I have this crate added to the cargo toml, I'm going to implement the new method. And this new method is going to be called come up with plan. So it will be used to ask the supervillain to come up with a plan. And it will return a string with a plan, whatever it is. Let me bring the duration into the namespace and explain the rest of the code. So here we're waiting for 100 milliseconds before the supervillain makes up his or her mind, and then we return a new string that explains the plan that is taking over the world, as every good supervillain knows. Now that we have this asynchronous code, I would like to do the test for it. And in order to do that, I'm going to go to the end of the test module, and after the last test that we wrote, I'm going to add a new one here. So I'm going to use the snippet that we had, and the name of this test is going to be plan is sadly expected. I don't know if this is very expressive, but it should do. And here I'm going to write the different parts of the test, but in order to do that, as we did previously, I'm going to use the test context attribute, and I'm going to use the context as the parameter for the function. Now that I have this, I already have the context created with the system under test here. Let me simplify the code here so we understand what we are going to do. And I'm going to just use an assertion. And the assertion is going to be assert equals. And inside of this assert equals, I'm going to invoke the method that I have just written, come up with plan. And I want to compare it to the take over the world string that should be the plan that the supervillain comes up with. And there are a couple of problems here. The first one is that come up with plan returns not a string, but rather a future of a string. So in order to be able to have a string, I need to await for the result. I need to poll that future. The other problem that we have is that this has to be consumed as inside of an asynchronous function. So this function should be asynchronous, and if we make the test asynchronous, we need to change the attribute because test doesn't like asynchronous function. We need to have Tokyo test instead. That's why we needed these two features in the crate. So I removed the other one here, and now I have a test that can be asynchronous. I still have a problem. That is that the context is expecting to have an implementation of the async test context trait, while our context is only implementing test context. So let's solve it. Let's go to the context type that we define here, and we're going to add to the implementation of context another implementation, which is going to be for the asynchronous test context. So that is going to be here, and I need to import this into the namespace that we're using. Now that we have this imported, I'm going to define the two functions or methods that this trait implements. So the first one is going to be setup, and is going to be very similar to what we had before. So it returns a context and is asynchronous. This is the main difference. Second one is going to be exactly the same as the one we had before, but asynchronous. So we are going to do nothing, but we have an asynchronous implementation of teardown. This also has a couple of problems. The first one is that asynchronous functions are not permitted inside of a trait implementation. So how can we solve that? Well, we can go to the console and now add another trait that is called async trait. And once we have added this trait, we can come back here and add an attribute to the trait implementation, which is going to be called async trait. And now it doesn't complain about the asynchronicity declaration of setup and teardown. But we still have a problem, which is that this conflicts with the other implementation because the names of the methods are exactly the same. The people who implemented test context may have come with different names for the asynchronous implementations, but they didn't. So we need to create a different type in order to be able to work with it. So I'm going to create another type for the asynchronous context. It's going to be exactly the same as the one we were using. So as an asynchronous context contains a system under test, which is a supervillain. And now I need to change the types here. So I'm referring to this type rather than to the previous context. So I'm going to use asynchronous here, also here, and here. And now I should have all the asynchronous pieces that I need. But I need to change the declaration in the code so I can use this asynchronous context. Instead of this one here, I'm going to change the attribute and use this one that uses the asynchronous context instead of the previous one, which was the synchronous version. So I'm going to delete this one. And obviously in the test, I need to use also the asynchronous version of the type. So now that I have that, I can go to the console and use cargo test. And yep, I have my test passing. So in our previous sections, we have been using cargo test and the standard syntax to write unit test. And that's very useful, but we can go a little bit beyond that. We can take advantage of other tools, and this is what we are going to cover in this section. These tools that would make our life easier and that will help us to do some other stuff. I would like to show you rustdoc in action. And I'm going to start by showing something that will be applied to the whole module. So this will be shown by its parent, and I'm going to add it here, and it's going to be using the // exclamation mark and the definition of this module. I could also use the triple slash and document the type that is in the next line. So now that I have that, I can go and run cargo doc, with these two options, with minus minus open and minus minus no depths. The first one is to open the browser with the documentation once it has been created. The second one is to just document the code that I have here rather than also including the dependencies. So I'm going to create the documentation and it shows me this information here. Now, as you can see here, I have this string that applies to the supervillain module rather than to the supervillain RS file that I had there. And if I go here to this module, I have this type defined. And if I go to the supervillain type, I have the definition of the type and also the string that I define as part of the documentation. Okay, now that we have this additional documentation, let's add a little bit more. Let's go into one of the methods, and here I'm going to describe what the method does. That should be your first line in the documentation of a module. So we are giving a very short description, short and sweet and to the point, and we can, using Visual Studio Code, use enter and get 3 new slashes to have the line that we want. So here I'm going to add a longer description of the method, and I could have even sections here using the markdown notation. So I can go and use examples here, which is very useful because now, let me get rid of the 3 extra slashes here. I can go and use this to include code in my example. So these 3 inverted tildes will be the beginning and the end of my code. So I can go here and add code that will be tested. So this is called a doc test, and it contains this code that is very similar to one of the tests that we wrote, in which we create a supervillain and we assert that the full name, the execution of the full name returns Lex Luthor. Okay, so that's good. Now that we have that, we can go and try to execute this. So let's go to the terminal and use cargo test -- doc. This will execute the doc tests only. In this case, the doc test is going to fail because we don't have a library. Doc tests are only meant for libraries and not for binaries. But there is a way around that, and we're going to use that. So the thing that we're going to do is we're going to go to the folder and we're going to create a new file. We're going to call this file librrs, which is what we create when we want to define a library. And here inside of this library, I'm going to import the supervillain module and import test common conditionally, only for the tests, okay? As we were doing for the main .rs file, as you can see here. Very similar to what we have here. Okay, now that we have this library defined, we can go to the cargo toml and change this a little bit. Let me get rid of the terminal, and here I'm going to define a binary. Yes, the same thing that we had. So notice that there are 2 square brackets on each side, which means that there could be more than one binary. In this case, there's only one, same name, using the source /main.rs, the same thing that we were doing before, and we are not going to run the test for the binary. But we are going to include a new library, and we will run the test for the library. The library can be, there can be only one library, that's why we don't have double square brackets here. And the name of the library, I decided to call it evil, and it uses this file that we have just created, which is source/lib.rs. Okay, now that we have this file, I can go and try to execute the code for this file. So I'm going to go here and try to execute cargo test now, and it's going to run the test not only for the library, but also for the doc tests, as you can see here. And it's telling me now there's some problem here, which we will solve in a second. Basically because we are not importing supervillain into the namespace, and it gives us the solution. But what we're going to do is show you before how to run just the libraries for the test, which is what I have here. And this doesn't run the doc tests. And I can also run cargo test / doc as I did before, and it will only run the tests that we have in the doc tests. Okay, so now that we know that, we can go here, and inside of this I can go and import the use evil. Let's get rid of the comments here, the extra comments. And now, as you can see, there's even syntax highlighting inside of the example. I can go and run this example, and hopefully I will have it passing. Okay, much better now. So finally, if we run cargo doc here, so let me just get rid of this one. Cargo doc, that should be, yeah. Let's get rid of the open part because it's already open, just the no depths. And if we go here and we refresh the content, we should have the example here shown as part of the documentation. Not only that, if we don't want to have this line shown here, because this is not something we want to show in our code, we can add a comment here, and this will still be executed. Let's run the cargo test / doc, but when I run the documentation again, and I visit this and I refresh it, this line has disappeared from the examples. Okay, so this is very useful. One more thing that I would like to mention here regarding the documentation is that you even have the ability to use lint, the linter, to take care of the documentation and warn you if the documentation hasn't been defined yet. So you can say here things like warn if there are missing docs, and as you know, the exclamation mark here means that this applies not to the next item but rather to the whole file. And you can use deny here, meaning that you will not compile if there are missing docs, or allow if you couldn't care less about the missing docs in this file. Okay, so that's it. By default, even if your tests print anything to the standard output or a standard error, that information is captured but not shown. Let me show you that. So if we go to the set full name here, and we want to print the number of components that we have, so I'm going to add this line here, println the number of components with this information, and I go to the terminal and create run the cargo test again. Nothing is shown here about this message. So the receive number of components, it is not shown here. However, if I want to see this information, because sometimes you want to know what's happening in your test, you want to have some extra information about why something went wrong. So if you use cargo test -- space -- show - output, then you will be able to get the output of each of the tests that have output. So in this case, for these two tests, I will have like receive one component, and this is the panic that I got, and receive two components because that went fine. Okay, the rest of the information is the same information, same summary, and so on. When you have added a lot of tests to your code base, you want to be a little bit more selective on the ones you choose to run. So let me first show you how to list the number of tests that you have, and you do that by getting into the terminal and running cargo tests dash 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 list. And this will go through your code base and show you the names of the tests that you have. Okay? Now that you have seen which ones you have, please notice that you have 3 that have the full name string and 2 that have from str. So I'm going to ignore a couple of those so we can play around with running ones or the others. Okay, so let's start by ignoring this one, and also I would like to ignore this one. Okay, so now that I have ignored those, we can come back to the terminal here, and I can choose to run the ignored ones only. Oh, so there is a typo here. And as you can see here, it has run exactly the ones that have the attribute ignore, okay? And it has, they both have pass. As we mentioned before, that doesn't mean that those tests get compiled. That means that they are ignored for execution. And in this case, they are the only ones being executed. The other thing that we can do is to run everything, but let me type it like this. So everything, and include the ones that have the ignore attribute. So now we have the 7 tests passed and even the dog test. Okay. You can also select test by name, and you could be getting something like test from str. And in this case, it shows us that one of the tests that matches that string is being ignored, while the other is being run. You can combine both expressions. So you can go and say, combine that this is ignored with, let me get rid of the extra strings here, with the string that defines the test, and then now you will have the ones that are ignored that match the string. Same thing happens with when you choose another string like full name. And here you will be getting like the 3 ones that have this substring. It doesn't have to be at the beginning of the test. It can be anywhere. And one of them is ignored. The other 2 aren't. And you can be a little bit more explicit on what you want to run. So for example, you can say, I want to run, again, the tests that are in the supervillain : full name. And now they have to start with full name because it's you're looking for the whole string. So here you only get this one. You don't get the ones that are regular tests, but only the dog test, because that is in supervillain full name. The other ones are in supervillain : test : the name of the test. So if you want to run everything that is full name, you can just use the : full name, and then you would be getting this one for the dog tests and this one, the only one that has full name right after the : to be run. You can be very specific about a test, and you can say, I want to run exactly this one. And exactly this one means, let me try to delete the extra stuff, means that I'm going to say -- exact, and then the whole name, letter by letter that you can select, copy, and paste here from the test list that we ran before, and then it would run exactly that test. Okay, hopefully, am I missing something there? Super test full name returns first name space last name. Well, there should be a typo here, so let's do it properly. So let's go to the list that we created before. And what we're going to do is I want to choose the name from here. So I'm going to go and say this one here is the one that I want to run. And I copy it. And then what I'm going to do is to go with the prior expression and type in, I pasted it instead of typing it. So I'm going to use exactly the expression, and I got one test passed. Okay? And that's basically it. You have a lot of options that you can use in order to choose one test or the other, and this gives you enough flexibility and to choose all the tests in a module, all the tests that start with some expression or that have that string as part of the name. So that gives you a lot of flexibility to reduce the time that you use in order to do some testing when you're focusing on some specific area of your code base. Sometimes it is nice to know how much of your code is covered by tests. And in order to do that, we're going to use some code coverage techniques here and tools. And I'm going to first install the tools that are required. And I'm going to go to the terminal. And the first tool that we will be using is LLVM Tools Preview. So let me get rid of the extra thing here. And this LLVM Tools Preview is installed via rustdoc. And in my case, I have already installed this, so it doesn't do anything. Second thing that we will be needing is grcov. That is the one that processes the data that has been generated by the LLVM Tools Preview, the one that tells you how much of your code has been gone through the test. And then this is transformed into a report, and that is done by grcov, that is installed as one of the subtools of Cargo. So this is installed via cargo install grcov. Having those two, the thing that we will be doing is we will be running the cargo test command. But the cargo test command is going to be run with some additional environment flags. So in this case, I will be using cargo incremental equals 0, which means, hey, recompile everything from scratch. Don't reuse parts that you already have there. I need the Rust flags. The Rust flags will tell the environment that this is going to be generating coverage information. And finally, I will be using the LLVM profile file, which is providing the name of the file that will be used in order to store the coverage data. That will be used with the cargo test. And as you can see here, the output of cargo test is similar to what we run in every other situation, but it has generated this additional information regarding the lines that it has gone through for each of the tests. Okay, now that I have that, I can go and try to process this, but first I will need to create a directory where I'm going to put the HTML information for the report. Then I will use grcov, and reading this information, it will generate some HTML report, as I mentioned before. And now that I have this report generated, then I can open it and browse it. So here you can see that, let me make this a little bit bigger. This is the report that we get, and it tells us that, well, some good amount of the code is being covered. And I can click here and then go into the additional modules. Let me make this also bigger. And I can go to the supervillain one, and it will show me line by line which ones are being covered. And notice here that this red one means that there is no test that is covering this situation. Actually, there is, but we had the ignore flag. Same thing happens here for the try from implementation. We do have a test that covers that, but it is not run because it is ignored. And you can see that happening here for this ignored test, and also here for the other ignore test, which means that if you want to do this properly, let's get rid of the coverage files that we created, and let's run the test again. But in this case, we're going to use the -- include ignored. As we saw before, this will run all the tests and also the ones that are flagged as ignored. So now we will be running them, and as you can see, all of them have run. So I have 7 passed. And if I generate the coverage information, the coverage report for this new data, I will get a different outcome. So the thing that you will see now is that if you refresh this code, suddenly everything turns green and the percentage of lines that are being tested is much higher. So that's what you need to do for coverage. My advice is that if you can, the reason why you want to have ignore might be different, but in most cases it's related to the speed of running those tests. So for the coverage, it's useful to run them all so you know how much of your code base is covered by your tests. The latest thing that I would like to mention regarding testing tools is Nextest. Nextest is an alternative test runner that provides us with some additional features, like the ability to detect flaky tests, or using a file to configure how the tests run, or detecting a slow test or delays, or even being a little bit more performant regarding the use of threads when you want to run tests in parallel. So the thing is that we're going to install it and see the equivalent command line to what we were doing with cargo test before. So let's go to the terminal, and here I'm going to install it, and you use it by using cargo install and go to the crate. In this case, since I have my cargo Nextest updated, I don't need to do anything here, but in your case, it might compile, download all the crates and compile them, and then you will have, after waiting for a few seconds, the Nextest available for your cargo command line. So now that we have Nextest, we can go and run the test, and this is done with cargo Nextest run. And cargo Nextest run goes and compiles the whole project again, and this is going to be a little bit slow because we are compiling the project from scratch, but basically we are going to use the test runner. And as you can see here, the main difference is that you have a different report which starts by saying that the tests have passed, and you have the duration of each of the tests, and this is the application, this is the package, and this is the name of the test. It also mentions here in the report that 5 have passed and 2 have been skipped. Okay. So if you want to list the tests that you have available, you can go and use cargo Nextest list, and you will see all of the tests that are available. Also, you can run the tests using strings, as we were doing before with cargo test. So here I add the string, and you can see that it executes every test that has full name and is not ignored. You can also use cargo run test full name, and that will also work, and it will also run the same 2 tests. Or you can use the : full name to specify that it has to be full name at the beginning of the test string, and yeah, that passes too. One of the advantages of using Nextest is that it provides us with a richer regular expression way of selecting the test that we want to run. So we can use something like cargo Nextest, run -e for the expression, and then use different expressions here. In this case, the second expression is repeated. Sorry about that, but it's just test full name. And any test that has the full name in the string as part of the test name will be run. You can be a little bit more specific. So here we got both the beginning and set full name that contains full name after the beginning. But if I now run this one here, I can be selecting the ones that contain full name, but ignoring the ones that contain set. So now I only get one test, okay? And the same thing can be done using operators. So I can go and use, sorry about that. Let me try to bring it here and replace and not with minus. And same thing, with this expression, we got the tests that contain full name and ignore the ones that contain set. So as you can see, Cargo Nextest offers a different user interface for the report and a richer way to select tests besides all these other features that I mentioned at the beginning. Well, this was all. I hope that this was useful to you. And if it was, I hope that you like the video and subscribe to the MongoDB channel, because we plan to create more content around Rust. I have some ideas about TDD and testing doubles that I think they are going to be 2 videos, probably as long as this one. So if you're interested in those or in any other topics that are related to Rust, let me know and I will try my best to cover them. Till then, see you.